satellite data in terms of the fire monitoring and wildfire analysis. In this case, in Portugal. I divided my presentation and for topics. First of all, I will explain who we are and what we do in terms of the products that we made in the last few years, and what are our needs. I think it's important. I explain our difficulties and what we do next year in terms of the next steps. Okay, the National Emergency and Civil Protection Authority is the authority in Portugal that has the responsibility of the civil protection emergencies. And into this organization, we have the Special Civil Protection Force. And this force responds to civil protection emergency. We have different capabilities. And today I will develop the wildfire analysis. And in this case, the group that developed this capability into the Special Civil Protection Force is GAUF, use of fire and analysis group. This group has today 29 members and works specifically and exclusively in terms of the wildfire analysis and use of technical fire. Here you can see the four main activities that we developed. Content development, I will explain a little bit more in this presentation, but the interaction with universities and our participation in national and international projects is one part important of our work. Also, we make fire prevention when we make the first fire burn, and some products about risk analysis. And in this case, also I will present one of them. About training. Training for us is very important. We develop more or less 60 operational training for the incident commanders in Portugal. And in these trainings, we developed the wildfire analysis and some procedures about that, and also the GIS tools that we made in the past. And the exchange experience is also very important for us because we learn a lot when we exchange experience with international teams. About wildfire suppression, it's our core business. It's here we make the fire analysis and use of technical fire. And for this, we have three different teams. Not there, you can see in my screen, is the decision support cell for analysis of rural fires. Is the main cell that we have at the National Command in Lisbon, and we have 4 people every day. And the most important work of this team is support the decision before, during, and after the event. And I will explain more or less 2 different products that we made in this team. AVRAC is the reconnaissance, evaluation, and airplane coordination. In this case, we have 2, more or less in the middle of the country. We have 1 analyst each aircraft. And the main mission of this resource is send images or videos or some analysis information to NADER. And after that, NADER treats this information and send the incident commander or support the decision at national level. And finally, the field teams, we have also field teams. In this case, is work into the incident command post, and the other members go around of the wildfire, and usually update the perimeters, and reposition the resource, and if it's necessary, make the fire suppression. And like you can see, we work in two different levels. I think it is very important to clarify. And we work in the strategical analysis and tactical analysis. And NADER represent here the strategical analysis because we developed one product. It is named Strategic Operational Analysis. It's the document, we update this document daily, and we send every 3 years, every 3 days to all the civil protection agents in Portugal. And this document, the main goal is to predict the fire behavior and the potential of the largest wildfires the next day. And the daily briefing at the National Command is also developed by NADER. One analyst tried to explain how is the wildfires and the prediction to next days. And in the tactical level, in the field intervention, we send from NADER by to incident commander the operational information. In this document, we send during the wildfire, and we predict the fire behavior, the evolution of this wildfire, and the tactical proposals. Here in this table, you have more or less how much documents we made in the last years. And conceptually, when we develop our products, it's important we have a good database, because if we don't have the good data, and in this case, you know, the wildfires change a lot, the fire behavior changed a lot in the last years, we need the local data. And we made a fire spread database since 2015. And now we have a good database. And when we have this database, since 2018, we developed also GIS tools. And in this case, we made a relationship. We put the database into the GIS tools, and now we develop also the decision support tools. For example, monitorization, I will explain later, but is the common platform that we use in Portugal in terms of the wildfire analysis and the fire management. And it's important understand these tools, and the main goals for us, the main goals of these tools is the fire prediction, because we work to operational people, and we try to change some approach in terms of the operational dynamics. And because of that, it's important that simplify the complex information in order to operational people understand well. And what we did, an environment of the co-production with universities, and in this case, the most important university is Instituto Superior de Agronomia, because this entity work together with us, go to the wildfires, and all the year we try to develop some products. I show you here 5 the most important examples. Of course, we have others. And in my opinion, the most important platform that we developed in the past, and like I said, since 2018, is disponibilização. Pad monitoring is the common platform. It's common because all the civil protection agents have access to this platform, and put information in real time, can put images, meteorological information, all the information that they can put. And also we have into this common platform satellite and meteorological data, and all the information that we need to work in order to work in the wildfires we have in this platform. And we don't need now see different platforms, different places on the internet. This platform simplify a lot the operational dynamics in the field. And after we developed some GIS tools, we also made some products. And in this case, I think the probability of fire recurrence is an important product that we made. And in this forum, I think it's important to share with you because since 1975, we have data, and we made a relationship between how much vegetation is available to burn between with the ignitions that we have in Portugal, how much ignitions in the last years. In the last years, we have a lot, and in this case, the incidents in the higher two levels, and this that we have 85% of incidents in the high level and the very high level, and in this case, it works very well for us. In the middle, you can see the fire spread database, and now the fire spread database is one of the most important products that we have to work in order to develop fire products. Since 2015, we collected more than 81 large fires. I said more because this number is in the final of the last year, in 2021. Now we are updating this data, and until the end of this year, we will have more than 100 large fires. The fire spread database is important because we collect the satellite data and meteorological data. They made the relationship between the fire progression of the large wildfires in Portugal. And why is so important for us? Because this database represented the reality of our reality in terms of data in Portugal. And when we have this data, we can make the relationship, for example, with the simulators. And we also developed a simulator in relationship, in this case, in environment co-production with the university. This fire simulator, it's made in the EUMETSAT project. And now we have the simulation report, and we can predict the fire behavior. And we make this report during the event and send also to the incident commander. And finally, my last example is the energy released during wildfires. Is the simple platform that we develop, and in this case, we collect the data by MSG. In this case, the hotspots, and every 15 minutes we have the data about the fire electric power, and we collect this data, and all the people can make zoom out or zoom in. We can that is intention, and can see in real time the one graph about some place, and know how much energy the wildfires spend during the event. And when we developed some products, of course, it happens some needs. And for example, I will give you two because I don't have much time. But for example, this graph that you can see on the left the screen is the coverage of the different data source used. When we made our database fire spread database, we used the data by satellite. We used the satellite data and also the data, airborne data. And like you can see in this graph, there are some hours that we don't have coverage of the satellite data, and maybe we need to improve that in order to we have better information. Also about the hotspot, in this case, power radiative energy. Sometimes when we have cloud covered, of course, we don't have good information. And sometimes we don't have any information. It is worse because our worst wildfires happen when we have cloud or cumulonimbus, and in this case, we don't have this type of information. And in my opinion, it's important information because it gives us an indicator about how much energy and how much intensity is our wildfire. The last year, I lived the big list. Today, I have a different strategy. My approach is give some points. The free access to all weather data is crucial for work in this type of the work, and I think we need to improve this type, and free access. It's crucial, free and easy access to data, and in real time. It's also very important. It's important to simplify the information, and in order to all the agents can use well this information. Extend periods with satellite coverage. I said I think it's crucial, and in my opinion, it's very important. And increase resolution for hotspot data. In my opinion, it's also very important because now we work more or less with 5 kilometers, and if we can, and maybe in the short future we can work with 1 kilometer is fine, because if we have good resolution, we can make some algorithms and make, for example, automatic fire progression in real time, and I think we can develop a lot of products if we have more resolution. I put here the collaborative European platform because I don't know. Sometimes I use other different platforms. When I say different, I say not European platforms because. The index that we use our European platforms, and the way that we have the relationship, and we say the government organization, sometimes it's bad. Collaborative is because I think we have data, we can share some data, but we don't have place to share our data. And when we need to make analysis to other countries, we don't use the platform because sometimes it doesn't have all the collect data. For example, we have our national platform. And finally, next steps that we try to develop in the short future is use artificial intelligence. And in this case, in order to define new fire behavior indexes. Why we need the other fire behavior indexes? Because a lot of the index that we use today doesn't work. And we import some index in the other place of the world, but sometimes the calibration in some territory of the updating for the fire behavior in the last years, sometimes we don't do that. And we now have more information. We have a lot of information about the wildfires in Portugal, and our intention is change the approach and change the index that we use. For example, we have now the results about the fire spread, the estimation of the fire spread through the first hours in the wildfire. We have good results for that, but we don't have, for example, confidence about the intensity of the wildfire. But now we try to improve this data. The artificial intelligence will give us scalability, and this type of scenarios is crucial. Scalability because the wildfires is so large, it's so complex, and we need to change our approach. We only can do that if we have good estimation and good prediction. We only can make good prediction if we estimate well. And we cannot estimate well if we don't have good database. And local database is important. We cannot use our database in order to analyze different countries. And second, we will try to put our simulation in automatic way. In this case, we need to create a platform to prioritize the wildfires because we have a lot of wildfires at the same time, and sometimes it's difficult. We don't have much resource to analyze all the wildfires, and in this case, it's important automatic the simulator. It's not also for that, but also it's not only for that, but also in order to send all the civil protection agents and facilitate the work in the field. And finally, build operational meteorology platform. It's the hard work. Now we have already the protocol with IPMA and the National Meteorological Institute in Portugal, and we will try and make some operational products with this platform, and try to make this available, this platform for everyone. This concept that we have, because for us, we need to translate complex information into operational language. We work to operational world, and we are operational people, and sometimes we have so complex information and so complex products, and the people don't use it. Okay. And thank you very much for your attention. I'm sorry, I passed my time.